And let's start off 8.2, permutations of different objects. I'm extremely excited for this lesson. I hope you're just as excited as I am. I know that the numbers are excited too. They are excited. Alright, let's look at our getting started. Evaluate without using a calculator. Oh, love this question. Whenever we're dealing with fractions, multiplying, dividing, divide before you multiply. We don't want to go 4 times 3 times 2 times 1 and 3 times 2 times 1 and then divide. No. Let's divide first. This is the Haya method. So we've got 1 divided by 1. Haya. That goes to 1. 2 divided by 2. Haya. 1. 3 divided by 3. Haya. 1. Hey, that just equals 4. Let's look at the next one. Do the same thing. 1 divided by 1. Haya. 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 Ooh. 6 times 5 now is all we got left. Hey, that's 30. Alright, let's go with the next one. 1. There we go. We're just cruising through here. Oh, we've got now 8 times 7 times 6. Ooh, a little bit bigger that we're going to have to work through. But that one we can work through and get 336. The whole purpose of this first part is to see that process of dividing first before multiplying. All right, on the ferry now. We're going from Vancouver to Vancouver Island. And we've got 4 different ferries, but we've got to go one way and return by a different route. So let's just look at that. We've got the island here, we've got Vancouver there, and we got 1, 2, 3, 4 different routes that we can take. If we go one there, we've got to come back on one of the other 3. So for every single option, if we go with the first one, the top one, there's 3 other options to go through. If we go with the second one, there's 3 other options for the way back. If we go with the third one, there's 3 other options. And if we go with the fourth one, there's 3 other options. So there's 3 options for all 4 routes. So the way we're going to do this, fundamental counting principle. On the way there, on the way back. And let's put down how many options we got. On the way there, I've got 4 options. On the way back, can't use the same one. 3 options. 4 times 3, that gives us 12 different possibilities. Now, if a 5th route was added, same thing. There, back. On the way there is now 5. On the way back, it's 4. 5 times 4, there's 20. And if we go with the next one, on the way there, on the way back, with 6 routes. 6 on the way there, 1 less on the way back, 5. 6 times 5, 30. The second number is always 1 less than the first. Interesting. So what we've just been talking about there is called a permutation. It's an arrangement where order matters. And let's highlight that part. Order matters. Permutation, order matters. And I'll discuss as we go through what I'm really meaning by order matters. You'll see as we go through. Okay, so we're going to look at the 7-letter permutations of Kelowna. And we're going to use fundamental counting principle. So the way we do this, first letter, second, third, fourth, fifth, sixth, seventh. I suggest you write out those letters. First letter, hey, there's 7 ways that I could choose that first letter. Then as we can see, the next one going down the line, the first spot, there were 7 options. One has to be used. We can't repeat. Order matters. Meaning, if we put it in the first spot, it's not in the second spot. So the second one now is 1 less, 6. I've used 2 up now. It means the third letter, there's 5 options left. I've now used 3. So then 4, 3, 2, 1, all the way down. We're constantly using 1 more. Multiply those together. That gives us 5040. Now we do this type of work so much where we take one number and go right down to 1 that we've got a notation for that. So 7, 6, 5, 4, 3, 2, 1. That is 7! It's an excited 7. Ooh, look at that. It's so excited that we give it an exclamation mark. That is called factorial notation. And we read it, we say 7 factorial. And it means multiply from that number down to 1. So then each one of those, 1 factorial, 1. 2 factorial, 2 times 1. 3 factorial, 3 times 2 times 1. 4, 4, 3, 2, 1. And then we just multiply them up. So in general, with n, we start at that number of n, and we always go down 1, down another 1, down another 1, until we get to 3 times 2 times 1 to finish it off. So it's always decrease by 1 each time. 0 factorial now. This is a tough one to kind of think of. 1 factorial is 1. That means really what it's saying is how many ways can I arrange one book? One way. 2 factorial. How many different ways can I arrange 2 letters? 2 factorial. 2 ways. How many ways can I arrange $0? Well, 1. There's nothing there. So I only have 1 way of arranging that by not picking anything. So like it says here, n factorial is the permutations of n different objects. If you can draw lines and fill in with numbers, that's a permutation every time. So when we look at a number, we say, ooh, that's just a 3. But now we slap a factorial in the end, and that gives it some respect. That's a 3! So like this, numeric reunion. When the numbers see me with you, they'll have to respect me. Okay, into your bit.ly link there. What is 5 factorial equal to? What does it mean? How can you evaluate that? And hey, you know what? You didn't pay big bucks for that calculator for nothing. Hey, this calculator can handle it. It's got the factorial notation in there. And here tells you your keystrokes. Under math, you're going to probability, and it's on the 4th one there. Put in your number, and then slap in the factorial sign. So because we're going to be multiplying so many things together, it's going to say a lot of times this. That's meaning 8.7 times 10 to the 10. All right, we got a puzzle going here. Ooh, we're going to scramble the word education and make a jumble puzzle and then figure out what is it saying. How many 9-letter permutations of education can be created? Well, we're using all the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them to begin with. We're using all 9 of them. So that would mean, with fundamental counting principle, 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. For the first space, we've got 9 options. Then 8, 7, 6, 5, 4, 3, 2, 1. And we could punch that into a calculator and multiply them all together. Or, hey, whoa, wait a minute. That's 9 all the way down to 1, which means we've got 9 factorial. We could punch that into our calculator instead. And when we punch that in, practice punching in for yourself. Make sure that you do get this number now. Make sure you know how to use your calculator. So that seems like quite a bit. There's 300 and almost 63,000 ways that you can jumble up the word education. Only one of them will actually spell the word education. So just as an aside, I know it had nothing to do with this question, but let's say I had these all on tiles, and I'm pulling them out of a bag, and I want to see what's the probability that I'm going to spell education. There's only one way to do it out of the 362,000. That would be the probability. Now, we don't always want to take all of the letters. We had 9 letters there. Maybe we don't want to use them all. For instance, Chico has 7 songs on his iPod. He has time to listen to 3 songs on his way to school. That's it. Just 3. How many ways can he get those 3 songs going? There are 7 choices for the first song, because he's got 7. But he listened to that one. He ain't going to listen to it again. Now you'd be like, what a letdown there. So then he listens to the second one. 6 choices. And then 5. 7 times 6 times 5, that gives me 210. But we could use factorials along this line as well. Because I know from our first activity that 765 was actually could be made up of taking it right down to 1. And then say, hey, whoa, those ones canceled off. So that 7 all the way down to 1 is 7 factorial. 4 all the way down to 1 is 4 factorial. Well, using the numbers that they gave us 7 songs and 3 songs. I can subtract 7 minus 3 to get that 4. Which then also gives me 210. That allows us to develop a new formula. Seven permutations. 7 permute 3. So this is saying, out of 7 objects, pick 3. I'll use the word pick just because it also starts with a P. So out of 7 objects, pick 3 of them and move them around and arrange them. And now you got a formula to go with this. And of course, luck would have it for you, that's on your formula sheet. So you don't have to memorize it, you just have to know when and how to use it. So let's just say, he only has 3 songs, and he's going to listen to those 3. That would mean out of the 3 songs, pick 3 of them. Or in other words, out of n whatever, pick that many. So out of 3 songs, pick 3. Out of 3 songs, pick 3. So now we've got 3 factorial over 3 minus 3 factorial, which gives us 3 factorial over 0 factorial. This is where 0 factorial can't be equal to 0, because then we would say, we're dividing by 0. It would be impossible to pick 3 things out of 3. We know that's not the case. So because of that, we've got 3 factorial, which is 6, divided by 0 factorial, and we're just showing again that 0 has to, out of necessity, must equal 1. So then which one of these formulas means 9p5? Out of 9 objects, pick 5 of them, and then rearrange them in orders. So what are the meanings of this? What does it mean? Put that together, write it down for yourself. What is NP0? What is NP1? What do they mean? All right, so I've got 8 students here. They're competing in a 200-meter race. Whew. There's a running. How many ways can they finish first, second, third? First question you got to ask yourself. Does the order matter that they finish? Yeah. First place is not the same as 8th place. First place is not the same as 3rd. Order matters. And you'll see as we go along here in the next lessons that sometimes order doesn't matter. But in this case, yeah, those are not the same. So I've got 3 spots. I've got first, second, and third. Let's do it with fundamental counting principle first of all. How many different ways can people come in first? Well, there's 8 students. We're going to assume that each of them are equally likely to be able to make it to that line. So there's 8 possible students that can get first place. Well, you can't get first and second at the same time. So that means it's not repeating. The second place is going to be a different student. There's 7 other that can get there. Then third place, 2 have already been used. That's 6. So 8 times 7 times 6 gives us 336. There's fundamental counting principle. But let's use this newfound trick we've got. NPR. And that equals n factorial over n minus r factorial. Well, the n, that's our total number. Total number of students is 8. Out of 8, pick the r value, which is 3 of them. I want 3 spots. So 8p3. And now we just fill in, substitute into the formula. 8 factorial over 8 minus 3 factorial gives us 8 factorial over 5 factorial. This is 8 times 7 times 6 times 5 factorial. The way I did this is I expanded it as far as I could until I saw the same thing in numerator and denominator. This is meaning 5 all the way to 1. This is also meaning the same thing. 5, 4, 3, 2, 1. Hey, those are going to be able to cancel off. Hiya, those babies. And I get the same thing I got with my fundamental counting principle left. 8 times 7 times 6. 336. Okay, looking at this question, this is referring back to the text example 3 there, where they've got vice president, secretary, treasurer, president. They've got those 3 positions. But whoa, we could do exactly the same. First, second, and third. What if I just said, hey, doesn't matter if you come first, second, third. Top 3 students. I'm going to take you, I'm going to send you to a good running camp. Does it matter if you come in first or third? No, you're going. There's no first, second, third. It's just whoever finishes the top 3 students, send them off. Order doesn't matter then for those first 3. Is it going to increase or is it going to decrease the numbers? Oh, and lucky you, this expensive calculator. Hey, it does it for you. For instance, if we wanted 58p3, I don't want to be going through and plugging all these numbers in. Hey, let's just go here. Math, back to probability there. We select the 2, second one, and then you put in the 3. So that 3 goes with that 3. And that 58 goes with that 58. All right, next one. Good chance that this is going to be a question on the diploma. First one. Second one, not so much. I'm going to do the second one first, and then I'll come back to the first one here, just to show you the process a bit. So the second one, B. 5PR equals 20. We got to figure out what R is. The only way to do these ones, plug it into the formula. N factorial over 5 minus, oops, not N. I'll write down the formula first, sorry. N factorial over n minus r. There we go, factorial. That's what NPR is. There, throw it up out of the way there. Now, let's plug it in. So we've got 5 for the n. We'd have to solve for r. So we've got 5 factorial over 5 minus r factorial. That equals 20. Well, I know what 5 factorial is. I can punch that into my calculator. 5 factorial, that gives me 120. Now, my r value, I'm starting at an n of 5. Out of 5 objects, how many could I pick? Well, I could pick 5, or 4, or 3, or 2, or 1, or 0. Those are my only options. The r value cannot be bigger than the n value. R has to be less than or equal to n. N has to be greater than or equal to r. Way of thinking of it all the way through. Your r value has to be less. I can do some guess and check here. That's really all that you can do. If you want, you can rearrange this. And I would suggest just go like this. Multiply. So we get 5 minus r factorial equals 120 over 20. 5 minus r factorial equals 6. So you could look at it and say, oh, we've seen this number 6 before. I know what 6 is equal to. 6 is equal to 3 factorial. We've done that one already. So that means 5 minus r factorial equals 3 factorial. Factorial on both sides. I can cancel it off and just say, oh, 5 minus r has to be equal to 3. In order for them to be equal, this before the factorial has to be equal to that. And then we just solve for r, and we get r equal to 2. But you know what? In most questions, you're not even going to see that. You're not going to notice that 6 was 3 factorial. So from this point here, we're going to do guess and check. Plug in your values for r. Which one gives you 6 at the end? And you only have to try 5, 4, 3, 2, 1, 0. When you get the right answer, you can stop. Now, the more important of the questions is A. The reason being is this right here, because that's a 2. Because that's a 2, we can algebraically solve that. Or if it was a 3, we could as well. 2 or 3 in that spot, you could be asked to do it. Okay, so the way that we go through this process, we know, again, started setting it up the same way. N factorial over n minus 2 factorial this time equals 56. And I look up at the top, I say n factorial, n minus 2. Which one's larger? N or n minus 2? Oh, n's larger. I'm going to expand that one. N times n minus, 1, bracket n minus 2. Oh, hey, I see the same thing that's underneath, the n minus 2. So I'm going to slap factorial, because it just keeps going down to 1. I can expand and then factorial from that point, because it just means take it from there down to 1. Or n minus 2 factorial. The same thing we did with the 5 on the other question. Those two are the same. They will cancel off. Equals 56. Now I'm left with n times n minus 1 equals 56. Expand it. N squared minus n equals 56. Oh, we've got a quadratic. Anytime you get a quadratic in this course, equate to 0 and factor. They could give you a cubic and have you factor cubics as well. My guess is, though, it'll be a quadratic. So now we get n squared minus n minus 56 equals 0. Sum product factoring. We've got n minus 8 and n plus 7 equals 0. Two different options. N is either equal to 8 or n equals negative 7. But wait. That's meaning out of 8 options, choose or pick 2 of them. Okay, that makes sense. The next one says, out of -7 objects, pick 2. Well, we can't have -7 objects to start with. That don't make any sense. Your n value has to be greater than 0. You got to have something to pick from. The r value has to be greater than or equal to 0. So n is 8. Now, we don't always want to just straight up guess and check things either. If we have something sitting that tells us NP3 equals 8185136, and this is from their example too. You can see it in your text there. When I do this work, I'm going to get n factorial over n minus 3 factorial equals that. I better write it. Then look at n factorial, n minus 3 factorial. Which one's the larger? Oh, n is bigger. That's the one I expand. And I expand it until I can cancel off those. I now have n times n minus 1 n minus 2 equals 185,136. That's going to give me a cubic. I could expand this, I could equate it to 0, and I could factor a cubic. That would be all great. But we're looking for 3 consecutive numbers whose product is that. So if you do the cube root is going to tell us the middle number of the 3 of them. So we'll try it out and see if that middle number is at 57-ish. Let's put that in the middle number and see if it works. 58, 57, 56. Yep, that does work. So then that tells us that we would have 58 for the n. 1 less, 57, 1 less, 56. So my n is 58. It's going to help with your guess and check a lot more. And hey, we're done. That was an exciting lesson. Do up those last 2 questions. Have a good one.